Okay, welcome to Cloud Data Driven Online User Group Meeting. Who am I? I am Jean-Joseph, working as a data engineer. I've been in IT for over 18 years. I'm located in New Jersey, originally from IT, and I'm your host for today. The rules are you guys are free to comment, but do it with respect. There must be no offensive comments. Feel free to keep your video and microphone off, and I have your chat disabled, so this way you guys are free to raise your hands, and I will let the speaker aware of that, so this way you can have direct interaction with the speaker. We are on social media. You guys are free to connect with us and follow us. Today's presentation is beyond the basic select, and then Deborah Melkin. Am I saying it right, Deborah?
You got it.
Yes, sir. She is the speaker for today, and then she is a member of the New England SQL Server user group. She's a speaker and Microsoft MVP as well. She's gonna tell you more about herself. We do have other presentations lined up. There's a tons of them. You guys are free to go and register for yourself. The next one is data analysis using Power BI for beginner. And we will have Pragati as our speaker. And the following one is Ahmed. He will present for us how to troubleshoot a slow running query in SQL Server and in Azure SQL. So you guys, I would highly suggest you to go ahead and save your spot. If you guys want to present any sessions, feel free to email me at jane.joseph@bigdatadriven.org, and I will be happy to schedule your presentation. And by the way, Deborah, it is an honor to have you today. Thank you so much for your presentation. You are free to start sharing your screen and introduce yourself and start with your presentation.
All right, so let me switch over. If you see me pointing off, facing this way, this is where I've got my teams. So just wanting to make sure that y'all, so I'm not ignoring you if you see on this side, I'm just looking over here. So as we said earlier, if you have questions, raise your hand or put up the little hand thing. I am going to take breaks in the middle, so I'll definitely want to take any questions that I can, and I will try to get to as many as I can during our time here. But I'm very excited to be here today. So for those of you who don't know me, my name is Deborah Melkin. I've been a DBA, database professional, for over 20 years. I mainly work with SQL Server, but I've done just a little bit with some of the other database platforms, just enough so I can do some damage. I mainly work in transactional systems, but I've done just enough with, data marts and warehouses, just enough so I can do some damage if needed. Whoops, and it looks like my presentation screen just went off. There we go. I hit the wrong thing somehow. All right. As John mentioned, I am a board member of the New England SQL Server User Group. We are based in the greater Boston area. We've been around for a really long time, and so, it's been a great thing to be a part of that group. I also speak for other events in the data platform community, whether they've been the SQL Saturdays or now Data Saturdays. I'm speaking Saturday for the Southwest, and some of the other communities, Data Weekender. So regular community speaker. I am an IDERA ACE class of 2020. I actually remember to wear my IDERA ACE shirt today even. So IDERA supports speakers in the community. I know it's been very hard for us this past year going virtual, but I just want to thank IDERA for supporting speakers and having this great program for the past several years. I won Speaker Idol at Past Summit in 2019. They weren't able to have it, so I am still the reigning Speaker Idol champion, and that's what I'm claiming for now until someone corrects me. But it was a tough group, and it was really exciting to be a winner. And as mentioned, I was awarded a Microsoft MVP in the data platform past November, so it still feels very new, but I'm still very honored by it. This is the unimportant stuff. The important stuff to remember about me is that I am the alto section leader of my choir. It's been very rough being virtual, and we're so hoping that everyone's going to be vaccinated and numbers will be wonderful so we can start singing together in person next year. I do bluegrass jams regularly. Those are actually starting to come up because we can do more outside. I'm very excited to try to get back to that. I've been learning guitar, and I have a mando that I keep neglecting. But I'm also kind of a bit of a musical theater geek. There are a lot of people in the SQL community who can out musical theater geek me, but I still have a picture of Bernadette Peters after seeing her in Stephen Sondheim, so there. No, just kidding. I'm a little loopy right now, but that's okay. That's who I am, and I'm looking forward to talking to y'all, getting into the data platform stuff, talking about the select statement, which is really the fundamental of what we do. Everything involves a select statement. If you don't believe me, let's put it this way. Has anyone not executed a select statement today? Anyone? And let me put it a step further. Has anyone not opened Management Studio? Has anyone not opened Azure Data Studio and opened a connection to the database today? Because that's all you have to do to execute a select statement. I remember having a profiler trace up and running and realizing that I opened my Management Studio, and all of a sudden I saw all of the select statements that were being executed. And I just opened Management Studio and connected to a server. I didn't even have a query open. But that's what the thing, select statements are so ubiquitous, and they're so the foundation of everything we do. When I do a T-SQL 101 session, I say if you can write a select statement, you can pretty much write anything because everything is based off of that select statement. And usually when we talk select statements, we think about stuff like this. You've got your pretty basic select statement right here. But those aren't the select statements that are necessarily the ones creating the problems. It's very easy to go from something like this to something like this. And by the way, normally when we talk about these things and we see these, we think of these as, we want to blame some third-party data layer. We want to blame Entity Framework, and we want to blame Hibernate or NHibernate or whatever third party it is, because yeah, I've got the scars from troubleshooting those queries, and they're ugly. This one, I created myself. I created by hand. Do you know how hard it is to create a query that looks like this by hand? But it's also easier than you think. And if you start to take a look at the different parts, I'm not doing anything that crazy, really. But when you put it all together, these are the things, and how we add these things and how we put them together, we start realizing it is the little things that we do to a select statement that we build on top of each other, which make them more complicated. And by doing that, that's where we can run into trouble if we don't pay attention to what we're doing. So what's our agenda today? So I kind of broke it out into two things. One, we're going to talk about selecting from what I'm calling fancy row sets. And I say the word fancy, and I do have that inflection, and I do put quotes around fancy because they really aren't that fancy. But these are the little things that we're doing to our row sets that we start creating the complications for. And then we're going to talk about the fancy column list from row sets. Again, fancy is in quotes because these are things we kind of do every day, or we don't think about them as being fancy, but they're things that we do that complicate things. Although, actually, one of the things I'm going to show you towards the end, yeah, I think it's cool enough that we could call it fancy, but it's still really cool stuff and really powerful stuff. So with that, let's get started. And the first thing I actually want to go over is the logical order of operations, which is how SQL Server takes everything and logically puts it together. And I'm going to put an emphasis on logically for a reason. I'll explain that later. But it's really important because I think a lot of what we try to do is we try to work around how SQL Server works. Oh, SQL Server is doing this, so if I write it this way, then SQL Server will behave a certain way. And I think we start from here. So the first thing, when you have a select statement, the first thing that SQL Server logically does is it looks at the table, because we need to find out where are we getting our data. We got to start from somewhere. So that's our first place. Then we start looking at join criteria, the on clause. How are the tables, all the tables involved, being joined together? What are those conditions? Then we have outer. So now we're moving beyond just join, but we're saying what may or may not have data, and how do I need to kind of fill in columns, or where am I putting those null placeholders, if you want to think about it that way. After that, now we're coming to the where clause. So now that we've figured out all the rows that we have available, we're now starting to edit those rows and limit to just what we need. Now we have the rows that we want. Now we're starting to do grouping. And when we think group, we think of aggregates, and we think of rolling up the data. And it's basically rolling up those row sets that we've already identified. From there, we can then start filtering on what we've just rolled out. So it's where, and then what we've grouped on for the aggregates, and that we've rolled up after that. And from this point, where do we go next? Now that we have our rows, now we can start dealing with our columns. So now, only at this point, we start thinking about the columns that we're selecting. And so now we're limiting our data in that sense. And from there, we do a distinct. So this is where it's really important to understand how a distinct is not a group by, because group by is rolling up our row sets. Now that we know our columns, now we're kind of flattening things, and things that look like they're duplicate rows just based on everything else that we have done. Now that we have our distinct, whoops, sorry about that. Hopefully y'all can hear me now. So now that we've done that, now that we have our row sets and stuff, now we can do our order by work. Now we can figure out, now that we have our rows, now that we have our columns, and we know what everything looks like, it's all flattened, now we can deal with our sorts. And at our sorts, remember, it's gone through everything else at this point, and now that we've sorted, now we can sit there and say, get our order together. And at this point, oops, now we can deal with top. So at this point, this is when that top row set is. So when you think you're short-circuiting, I only need the first 10 records. If you have a massive select statement, SQL Server has to process all of that before it can figure out what those 10 statements you need are, those top 10 records are. So that's actually one thing to think about it. And I think a lot of what we do is trying to work within this logical order of operations. So one thing I will also point out is I have a lot of reference things that I've looked at, extra information that you may be interested in. I do, if you're really interested in this logical order of operations, Itzhak Ben-Gan has something that he wrote, and it really goes into deep dive, and it goes into a lot more of the details of these things than what I have done before, what I can go into at this point in time. But I wanted to at least bring up the introduction because I do think that this gets into some of the other things that we need to deal with next. So at this point, let's get fancy. And by this means, let's start talking about those fancy row sets. So if you're advanced with SQL, if you've been using it for a while, some of these things I'm starting with, you're going to go, Deborah, that's not fancy. I write that all the time. But what I want to kind of bring out is it's those things that we do all of those times, those things we don't think as complicated. That's where we start getting ourselves in trouble because we don't understand how they get complicated. And once we start building those out, that's where we need to start thinking about, yeah, actually, this is kind of fancy. And we need to think about what we're doing and why we're doing it. So if you are, I want you to take that step back and relook at these from a different lens with me. If you're still getting used to SQL, this is great, and I want you to start thinking about how you're going to be working on these more complex things as you get those opportunities and grow your skills. So the first thing that we're going to do to get fancy is talk about a derived table. So what's a derived table? Put simply, it is a select statement that we are using as a derived table. Or we're using a select statement as a table, so we're calling it a derived table. Anything that we have in that select list, that column list, this is going to be the only things available to us. It's as if we're taking our table and we're shrinking it down. Sorry, I don't know why I'm having mouse troubles today. But again, this is what we're trying to do. So the derived table is simply a select table that we're using as a table. It's pulled up as part of the select table. It's pulled up at the select statement. It's runtime only. So there's no caching of anything. It is just creating a select at the same time as you're doing a select. So how do we make that more fancy? By creating a common table expression, or a CTE. Now, the one thing with a CTE is you'll notice in my sample statement here, I've got a semicolon. This is the longest I'm going to spend talking about a semicolon ever. What does that mean? So that semicolon actually matters when it comes to a CTE. And the fact that there's a semicolon before the word with, that actually matters. Why? So SQL Server for a while has been wanting us to use a semicolon at the end of every statement we do. It's not the end of a batch, but it's the end of our statements. And it matters for a CTE. And really that's because when it starts with the word with. This with keyword is used multiple places in SQL Server, such as backup database with compression. And if we know that, that's part of a whole phrase, but it's in the middle. And a CTE has to start with the word with. That's how we declare that CTE. So how do we know if that with is a portion of a phrase that someone didn't actually parse properly, or they didn't put something in, or it's bad, there's something wrong and SQL Server can't, work with it? Or how do we know that it's a start of a CTE? We use the semicolon. So there has to be a semicolon before the word with, especially if you have a batch. So if you have multiple statements, you need to make sure the semicolon is before the word with. I always use it beforehand just so I know it's there. If I was to just run starting that one batch with, and that's the only thing there, I don't need it. But I like putting it there because there's no confusion that I'm starting a CTE at that point. But essentially, a CTE is very similar to a derived table, except for what it's doing is instead of putting that select statement in my from clause, I'm moving it up here. So I'm kind of creating an alias of what that derived table is before I come to my from clause. CTEs have some really cool applications, so I do like them, but there are a couple things to note with it, and we'll get to those. We are going to do demos. I just want to kind of talk through how we're making everything fancy with these row sets and column lists before we get there. So at this point, what comes after a CTE? How do we make a CTE fancy? Ooh, what if we use views? Now, a view is an object, and pretty much all a view is a saved select statement. So we're taking that derived table and we're saving it. So it can be used by multiple select statements. It is just saving our select statement. That's all there is to it. But we can reuse it, which is kind of cool. It's got some fun applications. But we'll talk about those later. So, okay, so now we've got our view. How do we make a view fancy? Well, we create user-defined functions, of course. Now, user-defined functions have a bad reputation, and we'll totally go into why. But one way that if a UDF was described to me at one point was kind of a view that accepts parameters. Because again, you have a select statement in our from clause like you would a view, but note you can use parameters like you would a stored procedure. So we're taking it up a level, and we're taking that select statement, that derived table, and we've kind of expanded the functionality tremendously. Now, this is also where we start moving from those fancy row sets to those fancy column lists, because a UDF isn't just about tables. So you have table valued functions or table value user defined functions, but you also have what's called scalar functions. And we use those like we would use a column. So now we're getting fancy because now we've taken that concept and we've put it in our column list. So now we're getting to fancy columns. So how else can we create fancy columns in our basic select statements so they're no longer so basic? Windowed functions. Now, window functions, I will tell you, once we see some of those demos, those are fancy. And I think they're really cool, they're really powerful, and they're really flexible. So essentially, we know our aggregates, like sum. But what makes it a window function is this phrase right here, this over. And what we can do with this over clause, or this over portion of our function, that's pretty cool, and that's pretty exciting. So let's take a look. So now we're going to get into demos. Are there any questions as I switch over here? I don't see any hands raised, but I'll give you all a second.
Sorry, you guys do have access to unmute yourself. If you have any questions, feel free to raise your hand, unmute yourself, and ask. Thank you.
All right. So let's look at demos. And if you have questions, raise your hand. I will make sure to stop and take a look. So what I've done is you'll notice that I have a database here called Deb's Adventure Works. And all of these scripts are available online. I have a GitHub. You can get to that through my blog. I'll give you the references later. But essentially what I did is I took the Adventure Works database and I applied a script by Jonathan Cahellas, who works for SQL Skills. And so I've kind of expanded a bit. And I've actually made a couple small modifications so I can do better demos and show you what I want to show you. But essentially, it's the AdventureWorks database. So the first thing I want to talk about is derived table, so we can start building on that complexity from our selects. So the first thing is, let me make sure I've got my execution plans on. So as a basic derived table, I've got my sales customer, I've got my sales order header, and then I'm joining to this select statement where I'm doing some aggregates. I wanted to roll things up first so I can get those before I join to my sales order header table. So it's a pretty simple select statement with a derived table, and I'm running it, and I've got my results, but I want to kind of show you the execution plan so you can see a little more of what's going on here. So hopefully this is visible enough to people, but what you can see is I've got my customer table joined to my sales order header table, and then I've got my sales order detail over here, and you can see that it's rolled up along the way like the derived table has, and then I'm joining to my other two tables. And when we talk about logical order of execution, that's kind of how I put it. I wanted it to SQL Server to put my sales order detailed information together and then have it join up to my header and customer. And that's kind of, again, trying to work with how I'm putting it, and hopefully SQL Server sees it the same way. Now, the reason I kind of brought up that logical order, because we're writing to work within that. I want my from clause, and then I can have it join out. But what happens if I do a nested derived table? So you can nest things. So I can have a derived table with a derived table in it. So let's take a look and see how that works. So I've got my salesperson, and now I'm joining to a version of what we have before, adding a couple more things, but essentially I'm joining to my customer table, I'm joining to my sales order header, and I'm joining to that same first derived table that we looked at before. So I'm going to run these, and then we can take a look at the execution plan. And if what we see here, we see our customer table, salesperson, sales order detail, sales order head. So we're not seeing those aggregates that we saw earlier. So SQL Server is doing a couple different things, but it's joining salesperson, but salesperson is outside my derived table. So the way that we put this together, we logically thought that SQL Server would put together the stuff from everything in the derived table and then join out to salesperson. What SQL Server did is it said, I see what you're trying to do here, but I can come up with a better query plan if I do this. And that's what we have. And I think it's really important to remember, because it means that SQL Server isn't necessarily going to do your derived table logic first and pull all of that together before it does the joins out to some of the other tables. Because it can figure out, hey, I'm not using this, you're not using this, we don't need it. Sometimes it gets it right, but sometimes it doesn't. And the reason I wanted to point that out is because I've spent tons and tons of times performance tuning a derived table, and I've got it working great. And then I put a part of the rest of the query and I'm like, why is it still not performing properly? And I have a query in my mind from like 10 years ago, and I'm going, yeah, this is what I forgot to look at, and understanding that. So again, derived tables we use all of the time. There's nothing wrong with it. It's perfectly fine. But remember, as we start nesting and then nesting within it, we have to remember that we're trying to troubleshoot those execution plans, because things may not be how we would have thought that SQL Server put it together. But we've got to work with what SQL Server does. So it's pretty simple and it's pretty straightforward, but it is the foundation of how we start making these more complex select statements. After that, we can go to our CTEs. So making sure we've got execution plans running. So as I showed you earlier, the CTE pretty much just takes that derived table and we're kind of moving where it is in our select statement. So this is my derived table that we had previously. And now I'm going to take this innermost derived table and I'm making that a CTE. I am naming my CTE and I am putting the word CTE in it. You don't have to. I like doing it because it makes it really easy for me to say, oh, that's a CTE, and I know where to go to look to find things. There are a couple things in Tips in Management Studio where you can it'll actually tell you if you're at a CTE when you use aliases and such. But for me, I wrote the name, I see the name, I don't have to think about it as much. So, but you notice my syntax. This semicolon is actually not necessary because I have it here, but I put it in just to be extra cautious. But as you can see, I've got my derived table here. It's now a CTE. And when I join, I'm just joining to my CTE. And I can join to my CTE from within my derived table. So let me go through and let me run both of these together. And the fun thing about these demos is the times always change on me. So I'm curious to see what SQL Server is going to return time-wise. So I've got my two statements. They both returned. We can look, both return the same number of records. And when I look at my execution plan, I can look, query cost kind of lies, and we can talk about that later, but it's a relative thing. But this is kind of showing that the query cost relatively is the same between the two. And if I look, I can see that it's doing customer, salesperson, sales order, sales header. It's kind of looking like we already looked at that because in our last demo. And if we look at this one, it looks pretty similar. Customer, salesperson, sales order detail, sales order header. It looks pretty similar. So now let's look at our properties for our execution plans and see what other information we can find. So I'm going to go here, I'm hitting F4, and so I can now get my properties tab. Let me pin that so we're going to reference this again. One thing I want to do is I want to see how long it took. And I can see here an elapsed time of 463. And this one, if I look, my query time 472. So these actually took about the same number of time, give or take 10 milliseconds. All right, that's the same. But I'm still going back to the shape of this execution plan. So I have this query plan hash. So it tells me what query plan is returned, the hash for my query plan. And I have 4C6F32A. We'll just start with that because that's pretty close enough for us determining what I want to look at. And so now I'm going to go back here and I see 4C6F32. It's actually the same exact query. So it's a derived table. It's just formatted differently for this particular example. And I know a lot of people like using CTEs because they find CTEs easier to read than derived tables. Now, I got to tell you about CTEs. when I first got to use them, I was so excited. I put a couple in a store procedure and we sent it. It looked great. Sent it out to production. Week later, I heard back from my manager and he was like, yeah, so that store proc change you made, it's causing problems. We're having horrible performance issues. And I had to go back and I had to undo my CTEs. I actually had to go back to using temp tables because, remember, temp tables we want to avoid because temp tables are bad. But here's the thing with CTEs, they're runtime executions. So when you create a CTE, it's not like it's saving off the statistics somewhere for us to go back and reference. Eric Darling has a blog about this. You will find that in my references as well. So I didn't quite understand that point at the time, but I did do some research and I found that one website that I'm never, ever, ever going to find again that said, if you don't need a CTE, don't use it. Because there's certain things about the way it's constructed or the fact that it's runtime that you're not necessarily getting a performance gain. And depending on how you're using it, it may not be beneficial. So as I said, I'd replace CTEs I'd use CTEs to replace temp tables. So let's do an example. I'm just going to do the CTE, and then I'm going to create a temp table. That same data for the CTE I'm putting in my temp table. I'm doing the same select statement. Instead of the CTE, I'm using the temp table, and then I'm just going to drop the cleanup after myself. And so I'm going to run these. Now, for the record, we're going to ignore some of the things we see in the query plan because we're creating a temp table, we're inserting into the temp table, and that's going to have a cost associated to it. I want us to put that aside for just a moment so we can look at pretty much the CT and temp table by itself for right now. So we can see here we have a query cost we know is relative and not necessarily 100% true, but we have like 17% when we do the CTE and 11% for the temp table. Well, let's look at timing. And again, like I said, my times are always different. I'm always curious to see these. I got 500 elapsed second here. And then when I do the CTE, 589. Well, 89 milliseconds isn't a lot, but today, right now, my CT is a little bit slower than using a temp table. So here's the thing to remember. A temp table has statistics. It's an actual table. And in fact, the temp table I created has a primary key because it's a table. It's just living in temp DB. And yeah, there are a couple of different rules surrounding by it, but it's actualized data. There are actual statistics. So this is one of those things, and this is the example that I would kind of recommend to you when you're using CTEs. Think about where you're using that select statement and the data that you're putting in the CTE. Because remember, it's not materialized. There are no statistics attached. It is a part of that select statement at runtime. Think about how you're using it. So if you're using in a store procedure and you're using that data from the CTE multiple times, you may actually do better by doing a temp table because you've got that smaller amount of data. You're putting in a place with statistics, and you're not having to call those tables multiple times. So you're saving index scans. You could be saving time overall with your store procedure by working it that way. But again, CTs, I have nothing against CTs. I think they're pretty cool. So definitely test if you don't need a CTE. If you're saying, oh, I don't want to use a derived table, I don't want to use a temp table, I'm going to use a CTE. Make sure you do the test and make sure that you really are getting the query plans and the performance that you're looking for. And it may not just be query plans as well. It may be logical table scans and reads and all of those sort of fun things that you look at when you performance tune. So just make sure you test your code. So I had said a key thing. I had said when you need a CTE. So what are CTEs good for? When may you want to use a CTE? Well, that's a great question. How about hierarchies? I like hierarchies. Well, hierarchies are one of those things that when we used to do, you'd used to have like know how many depths of your of the chain you have to deal with, what the tree looks like, and all of that's pieces of information. CTEs have simplified it to the point where you kind of don't need to know that information anymore. So, and CTEs also have a fun ability where you can see anything that goes above your CTE. So the CTE can do a couple things. It can reference it can reference itself, and it can reference any CTE that has been created before it. So we're kind of nesting. It's not quite nesting, but there's a referential chain that you can do creating a CTE that's pretty powerful. That's also one of those things that you'll have to test for performance. But for hierarchies, it's pretty much going to, it's what they're designed to because of the way that they work. So in my database here, I've got a CTE, and I want to get the org chart for my employees. So the way I'm constructing with it, I'm constructing my CTE, declaring that. My from clause, I've got my employee, my table that I'm looking from, and I figured out what that top level of my hierarchy is. So I want to see who doesn't have a manager. That's my head honcho. Now I have a union all, and union all is required when you create hierarchies. I'm doing a union all. And then notice my from clause, that same employee table, but my join. This is to the CTE I'm in the middle of declaring, that I'm in the middle of creating, saying how we're pulling things up. I'm creating a self-reference here. That's just cool. This qualifies as fancy, right? That's just cool, referencing the thing that I'm referencing as I'm creating it. I have a little code here so we can actually start taking a look at the hierarchy. So when I run this, this is what I want to show you with a hierarchy. I'm able to create a visualization of my hierarchies and the different levels. And I didn't pay attention to anything about the depth, how many levels of my hierarchy I'm dealing with. I'm connecting things with the record beforehand. And I'm really able to show kind of, with the way I'm doing here, it's almost a visualization in a sense of my hierarchy, of what my org chart looked like, how far depth, how many people are here, and so on and so forth. So this is actually a pretty cool thing, and it's pretty powerful if you ever have to do hierarchies and show those levels of display really quickly and pretty easily. So any questions, Ed, about CTEs or what we've talked about so far? All right, if you do, you let me know. So at this point, I'm going to continue, and we're going to talk about views. So as I said, views are really cool because all views are is that single select statement saved off as an object. And actually, when I talked about CTEs, CTE is a single select statement. One of the things with views is you can't do things like have temp tables. A CTE, if you have one temp table, CTE can almost replace it. So you can use CTEs in views, which again, that could be pretty powerful if you need to have a view of your org chart. But getting back to what a view is, let's look at a basic view. And I'm using this from AdventureWorks. I've kind of cleaned up the formatting from what got scripted out. But this is a pretty basic sales view of salespeople. So I've got a salesperson. I'm got my inner joins to other tables. I got a couple outer joins. Pretty basic. A select statement with a lot of joins. So now I'm going to select from the entire view itself, and I'm going to make sure my execution plan is on, and we're going to do a quick select. And I'm just selecting all the columns. And when I look at my execution plan, it's kind of what we'd expect to see. I've got you see all the different joins to all the different tables because I'm selecting from everything. So now let's start modifying our select statement. Let's use this view as a join, because we're using a view as if it were a table. It just happens to be our select statement just happens to be saved off. So I don't need everything that I did before, so I'm just selecting what I need, the select statement from what I need. And when I look at my execution plan, I'm seeing everything that I'm doing and all the different underlying tables from my view, like person, business entity, employee, sales territory. Over here, I've got my phone and email, but hang on a second. I'm not pulling back anything from phone or email. And there are a couple other tables that were in the view that I'm not seeing here. So this is why views also have a bad reputation and why people don't always like views, especially once you start getting into nested views. That can be a whole session by itself. So SQL Server can be pretty smart when it does select statements. It can sit there and say, hey, I notice you're not needing this table here. We're not pulling out anything, like email address. You're not pulling out anything from email address, so I'm just going to ignore it. And you notice that not everything from the view is here either. So SQL Server was smart enough to figure out it didn't need some things. It's not smart enough to figure out it doesn't need all the things. So because it's doing the view, it can't quite figure out what it needs to take out for whatever reason it is. Because remember, SQL Server has a very, very short time to come up not with the best plan, but the good enough plan. So sometimes with a view, it makes it harder for SQL Server to figure out what it needs and what it doesn't need. Here, it didn't quite figure it out because really, this is what you're looking for. So instead of making SQL Server go through this view and all of these joins, we're just doing the select statement of what we need. And when we run this, we can look at the execution plan and we have this one when we try to do with a view, or we can do this nice, clean, smaller one here, which is going to be faster in almost all cases. So this is where views are not necessarily evil because they can be good for creating stuff for reports, for example, but they're not going to necessarily be something that you want on a day-to-day basis for your regular code. It's just, again, SQL is tell me what you want, only what you want, and the less SQL Server has to figure out, the better you're going to be in some cases. But we can get fancy with views. So you can actually put indexes on views. I know there are certain versions of SQL Server when this was introduced for beyond just enterprise level. And of course, there are caveats, but let's take a quick look at what an indexed view is. These are also sometimes called materialized views. And let's examine why that is. For the most part, our view is pretty much a standard view. It is still our basic select statement. But there's one main difference here. This with schema binding. This means you can't just change a table underneath because this view needs this table to look the exact same way when it was created. So this prevents you from, so if you have to change an underlying table, you need to drop the view, then you can change your table. But then I'm creating a unique clustered index on my view. So let's think about what a clustered index is. A clustered index is a copy of all the data, and so you can find it easily. And these are these two columns are the main columns of it. But essentially, a clustered index is a copy of every single data for that, I'd say, table, but now it's the view. So now we have captured a copy of the view and what the data looks like. So this is a really important thing to kind of think about because there's overhead. If you have tables which have a lot of changes underneath, you're going to have overhead because this index has to be updated with all of that information. So now we've kind of complicated our update statement for a table because now this view has to be updated as part of it. And we didn't even realize that needed to happen. But it's kind of cool because now we have an index on a view. So let's see what that means. So I'm querying my view by itself. So I'm querying everything. And because I don't have a where clause, it's actually looking at all of the underlying tables. It's not using the index because, well, the index doesn't help it. So now let's use it as part of a join. And it's a pretty simple join, and I'm not doing much in terms of where clauses or anything like that. A pretty simple select statement using my indexed view. And this one is a little longer of a select statement because I didn't use a where clause. My bad. It should be done another couple seconds, hopefully. See, this is why you need where clauses on your select statements. But we can now see that it's actually using my index. It's a scan, but look, I'm using an index on a view. I'm actually not using those tables. I'm using an index where I have all my data. It's pretty cool, pretty fancy, right? So let's expand upon that. Let's add another table, and I'll add my where clause now because we should always use where clauses in production, right? So it still takes a little bit to run. It's done. I'm looking at my execution plan, and as I scroll through, we see that it's not using the indexed view or the index on my view. Because just like tables, we can create an index, but SQL Server Engine may decide, you know what, that I'm not getting anywhere with that index. I can't use it. And so in that case, for an index view, it's going to use the underlying tables. So whether that helps you or not, it's just something to think about. Just like everything else, every other index we create, how is it going to be used, or is it going to be used? So, but it's a cool functionality, and if it helps you, even better. But make sure you're using it in the correct places. So now I'm going to talk about that next level, that UDF. I'm doing a quick check to see if there are any questions. So I get a little something to drink. All right. So we'll talk UDFs. Now, user-defined functions, as I said, have a very, very bad reputation. So in addition to setting execution plans on, I'm going to show you some statistics. So that's my set stats IO on. I'm actually going to start with a scalar function first. That's the one where we use it like a column. So from the AdventureWorks database, I have this get product list price function. And so I'm passing in 2 pieces of information, and I'm going to get a single value back, a money value. And essentially what I'm going to do is I'm looking at these tables to get the price history at that point in time. So here's my select statement. You can see that it is called as part of a column list. And as I run this, taking a second, my machine's a little slow today. All right, we can look and I can see the sales order detail, and I can see the product. I'm looking for product list price history, so maybe these don't have that. Wait a minute. And it's not in my query plan either. Wait a minute. Well, I'm calling this function. I should be seeing this stuff, right? But I'm not seeing it in my actual execution or the execution plan with my runtime statistics. So let's just get the estimated execution plan or without the runtime statistics. And now I can see my I can see what's going on for that function, which I couldn't see before. And that's actually part of the reason why people don't like scalar defined functions, or because you can't see the cost right now. We're going to come back to this. I'm going to come back to this one because there's a little more that I'd like to explain. But I will point out that we don't see it here, but really, this is what we're looking for. And when I look at statistics and the stats for both of these, again, it's taking a little bit. But when I look at the execution plan, it looks like this one costs a little bit more. But if I were to look at the time, this one takes less than 800 milliseconds. And this one, this query stat, took 4 seconds. So this is where query cost is starting not to tell me the truth, because there's something more that's going on here that I don't know about. I'm going to come back to that one. Let's move on to the table valued functions. So we'll finish up with the fancy row sets for a second here. There are 2 types of table valued functions. You have your inline table valued function, and you have your multi-statement table line function. And I'm sorry, I'm getting a little bit noise. Can y'all please make sure that you've muted yourself? I'm hearing a little bit of an echo. Awesome. Thank you so much. I don't know if that was a question. If so, please, if you want to raise your hand, I will get to that in just a second. We have our inline table valued functions. So pretty much the first one is your inline table value. I know I've been saying that. All right, so we have our function here, and it's pretty much our select statement here. But notice I'm accepting a parameter to our select statement. So this is where it's kind of like the concept of a view. I have just a select statement, but now I can pass a parameter directly to that select statement. You'll notice like it also has the with schema binding, which means you can't change the underlying tables without getting rid of the function first and then recreating it. Kind of like that indexed view, the materialized view. But it's pretty simple to use. I've got my function, and I'm using it here. I'm passing in a parameter to the function, and I'm using it as if it were a table. And when I run this, it's pretty clean. And when I look at my execution plan, I can see everything that is running. I can see my employee, I can see my salesperson. I'm seeing everything that's run. So this particular example is actually used from a SQL Server piece of functionality called security policies. I don't think a lot of people use it. I heard about it because I think Adam Mechanic did a presentation and he talked about it. And I'm like, oh, table valued functions. That's really cool to see how it gets used. So they do have a purpose. And table valued function, inline table valued functions, we get to see what they're doing. We had that problem with scalar functions, but we don't have that problem here. We see all the cost, we see all the records, and we can see all of the table scans and the logical reads and such. So there is another type of table valued function called multi-statement table valued function. Now, these are the ones that really have a bad reputation to them. So here's my example for the AdventureWorks database. You can start to see the difference already. The first is we are declaring what the table looks like. So it's creating a table variable, and we're declaring all of that information as what we're returning. So we have names, we have data types, we have nulls and not nulls, just like a regular table. And the other thing is multi-statement table. So we have multiple statements. So look, I've got multiple statements going on in here, and if clauses and logic. So it's kind of like a stored procedure, but I get to use it directly like a table. Okay, that qualifies as fancy, right? But there's a couple issues with it. So let's start by selecting by the UDF by itself. And let's look at the execution plan. There, I don't see all that logic that it just did up here. I executed it and I'm not seeing it. And if I hover over my estimates, well, I was only looking for one, but I got 100 estimations of records. That it thinks that I'm getting 100 records when it actually read one. Hang on a second. Let me look at my estimated execution plan here. Okay, now I see all the work. So kind of like the scalar function, I'm not seeing what's going on. And if you're trying to troubleshoot something and you have a multi-statement table value function, we're not seeing all of this as part of our execution plan. That's problematic. Like it's going to create a lot of problems. But also remember, that query estimator only thought one. It only thought, or sorry, it thought 100. So it thinks that 100 rows are being returned. And the thing is that two things. One, that's on purpose. And two, that's actually an improvement. Because when multi-statement table valued functions and user-defined functions were introduced in SQL 2008, that value used to be 1. Now let's think about why that matters. I'm going to select joining to another table. And that's where we get into why the cardinality estimate and why that 1 versus 100 as an estimated number of rows matters. So for this statement, I have 156 people that I'm returning. And SQL Server thinks that I'm going to get 100 records from my user-defined function, my multi-statement user-defined function. Can't see what's going on. It's not figuring that out for me, but it only thinks 100. So this is where the choice of a nested loop versus a hash match versus a merge join and which operator SQL Server is using to combine everything starts mattering because it's based on that cardinality estimate. And if that's wrong, we've got a bad join property here, and that's going to cause performance issues. So, and again, we can't even see in the execution plan the tables that are being involved. In fact, all we get is this, there's a temp table somewhere that SQL Server is using or a table variable that SQL Server using to return that. So we're not even getting any information when we run this to see what's going on. This is why people don't like multi-statement table valued functions, because really this is what we're trying to run. And we can get everything correctly. We can see everything. But this comment right here is kind of key, SQL 2017, because I'm actually been running all of these UDFs against my 2016 instance. And we now have 2017 and we have 2019. And this is where it matters because SQL Server and Microsoft has been hearing us and being like, they improved 1 to 100 for multi-statement table valued functions, but that's a finite value. 2017, SQL Server started making changes for the better. So now it's called inlining. So I believe it's called inlining. I have it down here in just a second. So now I'm on my 2017 instance, and let me show you kind of what it's doing. Before, we couldn't see what was happening when we ran the query. So I'm running my UDF by itself. And when we look, well, we're still not seeing what's going on here. And that's still a problem with multi-statement table valued functions. That hasn't been fixed. But we are getting fixed is this cardinality estimate. It's now 1. It's SQL Server starting to figure out what it needs to be, and now we'll kind of figure out those rows so we can now start doing joins better. So let's check that UDF join to another table, the same statement that I had before. I'm going to look at the execution plan. Let me look at the cardinality estimate, and it's still estimating 100 rows. Did this work or did it not? The key is my statement, and I'm using a cross apply. Cross applies are not joins. So I have a blog post here about the interleaved execution. That's the phrase I was missing before. So for multi-statement table valued functions, you can't use a cross apply to have the interleaved execution. So SQL Server is not going to figure out the number of rows that UDF is going to return for you. It can't figure out beforehand if you're doing a cross apply. So let's change it to a join. So I've created this dummy function. It's not the best function in the world, but it's a multi-statement table valued function. Technically, it's really just a select statement that I'm inserting into my table variable that's being returned. So it's pretty simple. So let's actually do a join and see what's going on here. So now we've got everything in place. Messages, we're still not seeing the details of the underlying tables as part of our stats. We're not seeing it part of the execution plan, but what we are seeing are things like, where is it? Here's our table scan of my multi-statement table valued function. And now we can see that the number of rows per execution is 17. It figured it out first. So now when it does the join, it can figure out if nested loop was actually the right type of join, or if I had a greater dispersity, did it need to do a hash match or a merge? But it can now have the better cardinality estimates for it. Now, I put the scalar functions from 2016 aside, and I did that for a reason, because nothing happened with 2017, but for 2019, they're inlining the query, or inlining the statement. So we can now actually start getting costs for scalar functions. So let's go back to look at those queries again. Same exact queries that we looked at before. My function is here. It's in my as part of my column list. So when I run this, I can look at my stats, and hey, my product list price history is here. And when I look at my execution plan, hey, all of this stuff is here. It's a very different query plan than what we saw earlier. We just, we didn't see any of this before, but we noticed it took a couple extra seconds. But here's what we also need to start paying attention to what we're doing within our scalar functions. I had 34,000 records being returned. My scan count of this table, 34,000 records. These match. So remember, this is an inline statement. So essentially what our scalar function is a correlated subquery. And the way the correlated subquery works is for every record being returned, remember, logical order of operations, first we get all of our rows and then we deal with our select statement. So now we have all our rows. For every one of our rows, it has to go out and do our select statement for a row. So now we have a scan count of product list price history. So this is 4 seconds. We know we can get it under, 800 milliseconds. This is now we have more information from our scalar function as to what we need to do to tune it. Again, this is the sort of thing that why scalar functions have a bad reputation. So I also have the same thing for the multi-statement table valued function. For the interest of time, I'm going to leave you to play with this later, but it works the same in 2019 as it does for 2017. So I don't see any questions yet. So we're going to go into the fancy row sets for windowed functions. Again, I'm going to skip through some of these for the interest of time, but you'll be able to play with them later. So I'm going to don't remember what I wanted stats on, but I'm turning those on anyway. But I wanted to first talk to you about row numbers because that's pretty cool. We've all had the situations where we had a row set and we needed to return the number or some sort of numbering for that row based on what's being returned at the time. We didn't want to dump it into a temp table with an identity column because that's also a pain. And this is also how we used to write those. And it's a pretty funky select statement. Look, I'm joining on a greater than or equal to. I mean, that's kind of crazy stuff for join criteria. You're kind of like, ew. But we don't have to do that. We've got row numbering to do it. And I can order over my product number. So I'm now creating an order. So now my select statement, I can create row numbers. And I want to order by that because that makes more sense when you're seeing it. Oh, good, I have my row number and here's everything in that order based on my product number. And we can try to do filter. We only want the first 13 records. So let's run this. This is again where that logical order of operation kind of kicks in. Window functions can only appear in select statements or order by clause. I can't put it in where clause. Why? We don't know what that value is yet. So this is where our friend the derived table comes in. I can put my statement in the derived table and then I can add my where and order and it all works beautifully. But as I said, window functions get pretty powerful. And so that's when we start dealing with aggregates. So I've got a couple different aggregates in this statement here. I'm using some. But notice my over clause. Like I said, this is where this gets really cool, this concept of the partition. And I have different levels of partitioning. But also I want to point out something else. I have an aggregate. Notice what is missing from my select statement. I don't have a group by. This means that what I'm summing here, this over partition by is creating different grouping levels on a row level. And when I do it this way, because I'm selecting for customers, I'm able to split it out over my entire row set and return a row set aggregate on an individual row level. And that's pretty powerful. As I said, I'm only returning for one customer, 33 rows. My quantity by customer is pretty much how many rows I'm returning, 33. And you can see the different breakouts. How many order, for customer order product, well, for each order, I've only got one product each, so that's one. But how many products per customer? How many quantity by customer and their order? How many orders, how many times did the customer order a product? How many products were in that particular order? And I'm able to get this information. I don't have to do subqueries. I don't have to do any sort of funky logic. I can do it with one single select statement. The flexibility of that is really cool and really huge. Because this is how we used to have to write it. We used to have to do derived tables and different groups and levels and kind of create that. I have a much smaller, much faster query because I only have to get that information once because of my windowed functions. You'll be able to play with these later, but let me show you the other thing that's really cool. How about rolling aggregates? Have you ever had to write that report and you needed to have everything kind of summed up? I have this order, and now I need to see this order and the sum of the two orders and third order and sum of everything up above. I can do that, and I'm throwing lag in here as well so I can see what happened before. And I'm adding more customers here too. So I can look through, let's say, this order right here. We have an order for $3,700. It's the first one, so there's no amount, but now I can see cumulative total. Now I've got my second order. I can now see what they ordered before, and I can see what they've ordered up to this point. How many of those reports have you had to write? And we've just simplified the process by allowing windowed functions to do that aggregate levels on different ways on a row level over larger portions of my entire result set, my entire row set. the flexibility is huge. And when I first was able to use this in production, I was like bummed there was no other DBAs there that I could party with, because that was pretty cool stuff. Any questions so far? All right. Well, I know oh, I do see a quick question. Joe, you had a quick question? Or John, I'm sorry.
Just John, yeah. Can you control R so I can see that query again?
Sure. And I'm making these available to you, so you'll be able to download and play with these yourselves. But again, there's no group by, don't have a having, but this partition, order by, it's the rows unbounded preceding. That's what does that cumulative update. So it's pretty cool and pretty powerful. I think this qualifies as fancy.
Very cool.
Right? Okay, anything else quickly? I know we're running short on time. I always run over or run pretty close. So this is what I wanted to show you for now. I have a bunch of pro cons here, and again, I will make these slides available, but it's really important to think about when we're using derived tables, the pros and cons of them. Stuff like it's not reusable, but they're used everywhere, so that's a big pro. CTEs, they're great for hierarchical data, but if you don't need them, they can cause problems, and they're not necessarily faster. It's the same plan as a derived table in some cases. Views, it's reusable. They're great for reports. Index views can be cool, but it's still a view. It's still just a select statement, and it's still runtime. There's no, unless you've got the materialized view, you don't have the stats, and that index view may not be used anyway. But really, views aren't about performance. I have a great blog post from Grant Fritchie in my resources about that for you to read. User-defined functions. They've got the bad rap for a reason, and that's a pretty big con. But Microsoft is improving it, so there is a potential for improvement. So you got to really be selective about when you want to use user-defined functions. And again, windowed functions. I mean, that flexibility, that rolling aggregate, that's just cool. I mean, I'm geeking out. It's just cool. But you can't use them in where clauses. And yeah, there are some instances of performance issues. So you'll want to keep track, and as everything that you're doing, you got to keep track of performance. There are a couple other things that you can do that you make your select statements fancier. And I thought about going over some of these because these are pretty interesting stuff. And some of these are pretty commonplace too. But I realized at a certain point, I'm going to be showing you the same exact thing. Here's the syntax, here's how you test it, and you got to look at the performance. What's the query plan doing? What are the pros? What are the cons? And it all starts boiling down to the same thing. So I'm going to leave you with a couple final thoughts. There is no one silver bullet when you're trying to troubleshoot. I mean, your performance may vary. I'm using a small data set with AdventureWorks, but that's not what your production data is like. It may not even be what your dev database is about. But you got to look for the performance. What are you going to get the best performance with? And that's what's really going to be your deciding factor on what you're doing. So you just got to test, and then you're going to test, and then you want to test some more. Because again, everything changes, how you're doing things works, and you got to really make sure that you're making the best choices based on your data and your databases, because your mileage may vary. Again, I'm using the AdventureWorks database, which isn't the best design, but it's great for showing some of these examples. But that's not your production database, and your production database is going to work differently. My rule of thumb is to keep it simple. I don't like throwing things at it just because we can. And you want to make sure that you're making judicious choices. So if you have a choice, just keep it simple. Don't try to outsmart SQL Server's database engine, because you will live to regret it. We all have the war stories about that. But this is also key, and we really see this with the UDFs. Even if your code hasn't changed, SQL Server does change. And those changes are going to affect the way you work. That Cardinelli estimator changed between 2012 and 2014. They're making improvements on UDFs, intelligent query plans, and adaptive query design, the interleaved execution. These are all going to change the way that we've been working with what you've had. So if it worked great in 2016, you got to go through all of these steps to make sure it's still going to work great for 2019. I have a whole bunch of resources that you can follow up on. And if you have any other questions, feel free to ping me. I have my email. I am on Twitter. I have a blog. So I try to keep that up to date. And from there, you can also get to my GitHub. Here's the URL for that, and it will make all of this available. So please, if you have any questions, follow up. I'm happy to answer any questions that I have. But so thank you all so much for coming and spending your lunchtime with me. I really appreciate it. And thank you, Jean, for inviting me to come to speak today.
Thank you.
Thank you. I think you're muted, John.
Can't hear a word you're saying, Jean.
Jean, sorry.
Thank you. I was on mute. By the way, it was an amazing presentation, Deborah. Thank you so much for putting all of this together.
Oh, you're very welcome. Thanks for having me, and I hope y'all learn just a little bit of little something, or look at things new.
We did. If you guys have any questions, feel free to ask. We'll just keep your hand.
Jean, I have a question for you. You always say you're going to send out the recordings, and I never seem to find it. Can you send me last week's and this week's recordings, please? John Repass.
To be honest with you, I'm gonna do share best with you personally, but the thing is, I always share with the whole groups, right? Sorry about that, but I think you may need to review your spam box to see, for example, if my email go there, or otherwise I don't know what to tell John.
Yeah, maybe you could just send last week's again, and I'll look for this week's.
Yes, so I'll do that.
Thank you.
You're welcome. Do you guys have any question? Deborah, is it okay to share my screen?
Yes, I'll stop sharing.
Thank you so much.
Yeah, hello. I have a hello.
You have a question?
Yes, I do. I mean, are they? How about the script? Are they going to be available online?
Yes, they are.
Oh.
I put all of them on my GitHub as well, so you'll be able to download those. And I do include the script that I used for expanding the AdventureWorks database. So it's the the generic AdventureWorks database. You'll download that, and then you'll run the scripts.
Okay, great. Thank you so much.
No problem. I think you're muted again, Jean. I think I'm mispronouncing your name. My apologies.
It's okay. Sorry about that. Thank you. Deborah, would you mind to share the information with me, and I will email the group as well?
Absolutely.
Okay, perfect. Thank you so much. The recorded video will be available sometimes later. Thank you all for attending our webinar, and thank you so much, Deborah, for your presentation. I hope to have you next year. Have a good one, everyone.
Have a good day, everyone.
Thank you.
Bye-bye.
Can't wait to try rolling aggregates.